I mean, um, I did this using R, and it's just like 8 lines of code. But guys, there's so many amazing things. So if you stick with me today, you're going to be able to draw these things from scratch on your own. But well, I just wanted to mention that the reason why I showed you this graph is because I just want to encourage you to besides, I just want to show you the reason why you should draft. Because for me, if I was an executive, this is the sort of thing that I want to see, to see how things have evolved, because this over time. Then we're going to look at time series as well, but it really makes sense to kind of see things how have shaped up. Maybe if you're looking at a daily review to see how the transaction, visuals are so powerful. So yeah, let's dive right in. All right. So when we want to draw data visualization in R, we use the ggplot library, which is the grammar of graphics, right? So what the ggplot does is they're essentially about 2, 4, 6, 7 things that you need um, for you to draw this. You need the data, all right. Then you need some aesthetics, which means the x and the y axis. Then you need a geometric shape, which could be a bar plot, a cumulative plot, a density plot, a violin plot, a box plot, a line plot, you name it, whatever you want. But that's what you call geometry. Then faceting, yeah, it's like you need an object where you're saying, okay, let's look, say you're looking at 5 or 6 categorical variable, then you can facet, or maybe into 6 facets. Then you also need statistics, which is, are we following, is it a linear model, is it a polynomial distribution, is it a normal distribution? So the statistics essentially like refers to them. Then the coordinates, yeah. So the coordinates, we're saying we can have the coordinates. What's the distribution of the coordinates? We can have the coordinates on a logarithmic scale. Let's say you wanted to measure the distribution and the axis, and maybe we see that let's say you're measuring weight in kilometers, human weight and weight of a vehicle, and you wanted to see at what point does the relation. So those sort of things, you need maybe some logarithmic scale. I mean, there's so many use cases, but you need to look at the distribution first to say how is the distribution spread. Then the themes, yeah. I mean, um the theme is like what you see, right? The black and white theme, the color theme. Do you want there's even like a BBC theme. Yeah, yeah, a BBC theme. You can draw your graphs like and make them look like a how they like BBC, like British Broadcasting Corporate. They use R. They've got a team that's the and the package is called BB Plot. You can look for it. It's available on GitHub. So let's dive right in, guys. Let's look at maybe we can start with this complicated one because I just want to help you to appreciate R. Then we'll do the actual introduction later. But here we're just going to show you like how good it can get. Right. So I'm importing this dataset called the vehicle dataset. I've already imported it. So here's the dataset. It has got 7 variables, which has got the vehicle. The first one is called the vehicle, and it's just showing us the 1, 2, 3, 4, 5, 6, 7, 8. So what we then see that is just an index, right? A unique identifier. Then you've got the FM, then the mileage, the IH, LCMC, and the state where the vehicle is coming from, right? So we could have vehicle from Minnesota, California. This is an American data set, DC, in many other places, but we want to look at a few of this observation and how the relationship, right? So we import the data, then we will filter. You remember filtering? One way I could have done this to achieve the same result. So where you saying vehicle filter state is equals to California, um, then or state is equals to Texas or state is equals to Florida. Personally, I prefer to do it this way. I would say I'm going to just say V, then out minus for assignment. I prefer this way where I say vehicle, um, control shift my pipe, control shift M, filter. Then in my filter, I would say filter state, um, state in, right? I prefer the in method. It uh, filter state in. Then I would say C. Um, then I would say TX, comma, FL, comma, CL. Okay. So this lets you write short code. Um, you know. So if we run this code, let's do it. Okay, so you have your results for Florida, Texas, and California, which is what I did above there. But well, it's up to you. You can choose what you want. But I'm just going to. So STR means the structure of the data set. If we run this code for STR, we see like how the values are coded. Like this one is a double, and a character. Then it also shows you like how like num is numerical, and character vary how each of those values are loaded into the data set, right? So we've done the filtering. So it's like when we want to create a ggplot, um, this is the code for ggplot. I can here I just use the chain where I'm just chaining to say this is my data set. It's the V. Then I put the pipe. Then I say ggplot. Aesthetics. I'm no longer putting the data set here because I put it outside. Then my x is equals to 1h. My y is equals to ic. Plus the geometric point. So what it means is I'm using a point object, right? Then I'm going to facet by state. What it then does it creates some, like three types, same charts for same charts. The charts will be the same, identical, but the values only will be different. Then the GG title, you then add a plus. That's tilde. There's this sign there. It's just something that you just add. It just means a function of state, right? So GG plus the title. This is just a string to just name your table. Then subtitle again is just naming. You can leave that. Then there's this function called geomsmooth. Method equals to lm. For those who are doing masters in data science, or those who will be doing data analytics or whatever, or those who have done Stata, you know the linear model. I'm going to show you how you can do actually a linear model. It's more or less the same. So yeah, so I'm doing a geometric smooth. I'm smoothing my points and identifying a linear model. Um, then call color, which is equals to red. I want the line to be red. Then x continuous, scale x continuous, labor hours limit is equals to 0 to 40. So I'm scaling the data, right? Yeah, yeah, I'm scaling the data. And when I scale the data, it then helps me to remove any outliers that can create distortion in my points, right? So y continuous, I'm doing the same. Then I'm putting my limit. So it's something that you may want to do when you have done your principal component analysis. Okay, don't worry about principal, but it's something that you need to do later on when you're advanced, right? So this, I say that this video I'm doing it to just show how good it can get, and I've also done it with master students in my class in mind. So let's run this code. Right. So this is what we get. We get this nice plot here, which you can then show our bosses or supervisor. It's well labeled, and you can see the linear relationship or the line that are plotted. So we can see that there's a positive, there's a strong positive relationship between the labor hours and labor cost. Again, this is what this relationship is showing here, right? So let's proceed Oh, this one, I actually wrote this code in January 20, no, no, it was actually in March, April, but that time when COVID was on its peak, and I wanted to do something for the Minister of Education, but then I realized that I was swarmed up with work and a lot of stuff. But at that time, the ministry was really showing some poor visualizations. So, and I I created a lot of stuff, but this is one of those things that I was just doing during my under lockdown. Okay, so we have imported. I'm importing the COVID-19 data set, so it's quite big. Um, but wow, my R ran fast, so I've got my data. So it has got 400,000 observations and 33 columns, right? So let's look at the data. We have got the age, the the sex, the city, the province, the country, the longitude, and the latitude, and the geo resolution, um, among other things, among other things, among other things, among other things, among other things. Okay, so we'll be discussing the points that are important here. So I've done this mutation using the library called lubridate. So when people are capturing data in R, they they're worried about speed, right? They're not worried about the data types or consistency. It's just and this data is being collected from world over. So chances are there might be some inconsistency, especially when COVID was just starting. So I've used the you can then use the library lubridate to fix your to sort of tweak your data and to create that sort of alignment. So there are many functions. We will do a video session on the lubridate function on the lubridate library. So here I'm using dmy to say that read the data as day, month, and year, right? That's what I'm doing there. Okay. So here I'm getting a notification warning problem with mutate input date confirmation 1795 failed to pass input date confirmation 1790. Also, there's a date that failed to pass because it was improper. But the goal of this video is to just show you visualizations, not to diagnose this area and fix. But some of these areas you can just ignore them. Okay, so don't get afraid, don't be offended when you see this error. Don't mind the error, right? So let's look at this one. So if we look at the day, month, and year, it has been coded. um right, where's this column for the date confirmation? Yeah, you see those dates, they're now dates of the class date, right? Okay, so if you are like very zealous, you could then say class. You could look at the class of the date to say has it changed, right? I could say class dollar, then date confirmation, right? Then if we run this code, um we're going to see that the class is of date. But if I do the class, um if I do the class, I'm going to do the class of data, before the mutation, right? So it's showing me that the class character. So this is why I'm going all the way to do all that, right? It's just to show you that you need to be very careful with the data types. So when you import your data, don't just assume. Make sure that your data is coded well. Okay. So we now go into the part where we are creating the animated time series plot for COVID-19, right? Um, so what I'm doing is I've put my date outside, right? Data new, then I'm grouping by the date confirmation. So what I'm going to have is I'm going to have a count, right? And for each and every date, right? Then after that, I'm doing that's also I'm doing count, summarize, count is equals to n, then mutate cumulative equals to cum sum of count. So what I'm going to end up having is a cumulative count. To say if today there was one case, tomorrow there's two, then I'm going to have three, then tomorrow I'm going to have four, and if it jumps to 10, so that's what the cum sum will then do. Let's run this code a bit and see what we have. Okay, so we have this column so it's like I said, we have the first column, which is the count. We have the second column, which is the cumulative sum, right? So we are going to play around with these two. All right, so after that you're going to add that into a geometric into a ggplot, and then x is going to be my date confirmed. So that's where the time series part is coming from, to say if I have an x axis that has got a date and my y is the cumulative sum, so I'm going to see like it's going to be this cumulative sum 2, 4, 6, 8, 10, 12. So that's what my y is all about. Then I'm putting a geometric line, and the color is going to be red, and a geometric point. So the size, I'm going to give it a size of 1,5. Then I'm going to my geometric object, I've got a point and then a line and then an area, which I'm going to fill in red. Then I'm going to use a theme black and white. Then I'm going to title COVID-19 case. Then I'm going to use a function called transition reveal cum as far, right? This is the part that does the magic, right? So let's run that code and see. Okay, so whenever you do this, it's rendering, it might take some time, and this object is something that we can then change and use it for your business case scenario. If you're working for a company, that's what you can just adapt the code and make sure you just tweak it a bit, you get the results, right? So it might take some time, because this data set was huge. It's about 400 megabytes in size, so it's huge. So there we have it. You can see my plot is now there. I know we can improve it by changing the scales here. It's fine, but this was just a quick item that I drew. Let's make it more interesting. So if you want to save this, you can save it and then add it to your web browser. You can do that, right? You can add it to your financial year. If this is a business case scenario, we can actually do that. Okay, so it's the same. I'm tweaking my dates here using the library LubriDate. I can actually split and spin it. So let's just show you. We can see how you can extract. If you wanted to do a report for days, even for month, we can just have a column of any size and just strip that part using these sort of functions. So we're going to cover this extensively when you look at the LubriDate package. Okay, let's jump here. So let's do another one where this time we're doing an animated time series plot, and we are going to change a few things. So let's run this one. You already know, right? This summarize, this count, this mutate. Nothing much has changed there. So let's run that code. So this is it. It's pink, and I've just added it. But this is a nice looking plot that you can add that your business can use, right? As you can see. So let's proceed. Data completion, month completion. So I'm creating new variables. We covered this, right? Okay, so what I'm doing there, the data.new is an direct assignment where I'm saying I've got a data new $date. I am assigning the variable day directly and month directly, like right away. So it's called in place assignment. Yeah, I think so. So here I'm taking my data, then I'm filtering the month equals to 3, right? Because let's look at the data new, right? And look at let's look at this column, right? So as you can see, it's now coded in the month, right? 1 January, 2 February, something like that. And similarly, if we look at this, it's no longer the whole date. We have splitted the date into different columns, right? That's what we have done. So what I'm doing now is I'm filtering the month equals to 3, then I'll group by the day. First, it will group by the day to say, okay, if the day is 1, then you'll group by the country, right? So you have the day and the country. So then the summary is going to be done on the country, which has been grouped by the date, right? So I'm going to add this into a data frame, then which has got 3 items: new, oh sorry, the day and the country. So we will look at this new data set called new, which I've created, right? So it essentially have the count, the new, right? And the country and the count, right? So it's just tracking the country and the count, right? And the day. That's what I've created. So after that, I will then add this into and I'm now creating that part where I'm picking up some countries, right? So in this case, I'm going to use United States, France, and the United Kingdom. Then I'm going to plot them. So it's the same. We use the ggplot, and the x is equals to day. Then the y we want it to be count. Then we are grouping by the country, and so that we can color. We're manipulating the group because we want to color it. Then I'm going to use a geom point, right? Then after that, it's the same. I'm going to use transition reveal to actually create the animated plot, right? So let's run this code. Yeah, so it can take some time, but it's worth it at the end when you finish. So it's like I said, if you want, you can save it and have it running on your blog. If you want to advertise your work, that's what some of the things that you can do. Okay, then we can also do the same for a bar plot, but I might not show you the bar plot for the sake of time. But yeah, you just know that you can do it for the bar plot. Um, then we'll see if we can finish. I'm running out of time right now. I don't want to make this video very long. So you can see there my transition, my countries are moving, and you're seeing how each and every one is being affected in a dynamic way. Then so let's look at one more time. So it's the same. We're using it to summarize. Then we are putting the plot and the transition. I'm just adding a transition time and the month and the subtitle, right? So we're just going to run this code for the bar plot, right? So as it's still loading, let's see if we can start our introduction to data visualization, because this I'm sure I have now I've managed to show you, like, you know, some of the coolest things that you can do, like at a high level, how you can present your work in terms of a simulation. So that's what I've gone on to show you, so that you have an appreciation, that you can do amazing work there. So it's rendering. Yeah, so you can see my bar is my bar is racing and it's being filled with time. We can see how the things evolved over time there, right? Yeah, you can see the United States growing faster and UK slowly, the Germans slowly, you know, with time. And this is according to time. So in a business case scenario, this is something that you may really want to then do and show to your employees, right? So let's see the other one that's loading. Yeah, so this is the last part, and I think I'm going to end this video here. This one is just showing for each country, like how the speed and the rate for each country. So goodbye guys, until we meet again. Don't forget to, in the next video we are going to actually do the introduction to data visualization, and we'll be looking at very simple example. So let's just do a few of those examples. um, okay, so we've got the size which we can control. We can control the alpha, which is like um, the color, right? The alpha is like the contrast, something like that. Then we can all control the line type and then the grouping as well, right? So here I was looking. You remember the flight data set that we used for data manipulation? So here what we did is we say flights, we count the origin. For each origin we want the count, then we are sorting, right? And then we're creating a name for the count to equals to n departures, right? That's what we are doing there. And when we run this we create this object, this new data set, and when we run it, uh, we see that the number for those departures, right? Okay, so this is the same. Like whenever you see count, just know it's the same as group by and summarize, right? So we are grouping by the origin and then we are summarizing by the number of departures, right? Okay, cool. So now what you want to do is you want to visualize this data. So when you're writing you need the ggplot, then we need your data, which is this data set, then we need some mappings. Our mappings is equals to x is equals to the origin and y is equals to the number of departures, right? Then a geom column, we are creating a column bar. So the geom core will be, you remember we said this is like your geometric. You need some geometric object for you to plot. So we then clearly see that the EWR hit the highest, and but so that's it for the geom core. We can then add some labels and some themes on the same graph. um you know then let's see, we have added the, the points. You can see there that the graph is now labeled. um, okay, where is my graph there? um, okay, it's not. So it's my graph will be, because I've created a variable, it's now stored in this object which I can call by running. um, so this is my new object for if I was doing this for my bosses, right? um, so we're going to change the caption here a bit to you know okay, let's proceed, doesn't matter. So what I can also do sometimes, I can call the library called library plotly, library plotly, right? I hope I've installed this package because I want to show you something cool. So I can then say plotly and add this object here. Right. Oh, okay. We'll do this when you're looking at points, not for this one. But if you put plotly there, you make the points interactive. You make the object becomes interactive. So we will look at plotly. Plotly p. We'll look at plotly when we do maybe scatter plots. Yeah, I think for scatter plots this will work. You just need to add to wrap the object in a plotly function, not for this bar plot. Okay. So if you wanted to save, you can save and use a path, then your graph will be saved. Then the group by summarize in departures ggplot, it's just the same, and we are creating a geom point. Okay, let's run this. Okay, guys, we'll pick it from next time. I have to go for now. Thank you.